In this video, we'll learn how to solve a system of linear equation using matrix method. In previous videos, we learned how to solve a system of linear equation using substitution method and elimination method. Remember that substitution method and elimination method and matrix method aim to solve systems of linear equations, but they use different approaches to find the solution. In this video, we'll solve a system of linear equation with two variables, x and y, and also with three variables, x, y, z. Okay? Let's see this example. This is our system of linear equation, and we have to find the value for x and the value for y. Okay? First step is we convert the system of linear equation into a matrix equation. What we do basically is, here we have 1, right? If we don't have any number here, this means we have 1. Okay? So we put 1 here. For 2, we take 2 and we put it here. The same thing we do for 3, we put it at this position, and for 4, we put it at this position. Then we open a new matrix, or we call it a vector, and we take how many variables we have. We have x and y, so we put x here and y here. Then is equal to, we have 1 and 2, we put our 1 and 2 here. Okay? Second step is we find the inverse of the matrix. So we have to find the inverse of this matrix. 1, 2, 3, 4. It is the same one here. 1, 2, 3, 4. Okay? First step is we calculate the determinant, as we said before. We have to calculate the determinant. If the determinant is equal to 0, this means the system has no solution and we stop. If the determinant is not equal to 0, as we see here, it is equal to -2, we continue and we find the inverse, then we continue to the third step. So second step is to calculate the inverse. So we have to find the determinant of the matrix. So 1 multiplied by 4, 1 multiplied by 4 minus 2 multiplied by 3. 2 multiplied by 3 is equal to -2. So it is invertible, right? We continue. A inverse is equal to 1 over the determinant -2, okay? Multiplied by, we swap between 1 and 4. So we got 4 here and 1 here, and we multiply 2 by minus and 3 by minus, so we get here -2 and -3. Then we do the multiplication. 1 over -2 multiplied by 4, we get -2. 1 over -2 multiplied by -3, we get 3 over 2, and 1 over -2 is multiplied by -2, we get 1. Finally, 1 over -2 multiplied by 1, we get 1 over -2. Okay? So this is our inverse. Then we multiply the inverse A by the side after equals of the system of linear equation. Basically what we do is we take our inverse, this inverse, and we put it here. Okay? Then we multiply this inverse by 1 and 2. It is coming from here. You see? 1 and 2. Okay? So first row here is for x and second row is for y. Now -2 so x is equal to -2 multiplied by 1 -2 multiplied by 1 plus 1 multiplied by 2, 1 multiplied by 2, and this is equal to 0. Okay? Then y is equal to 3 over 2 multiplied by 1, 3 over 2 multiplied by 1 plus 1 over -2 multiplied by 2. So 1 over -2 multiplied by 2. And this is equal to 3 over 2 multiplied by 3 over 2 minus 1, we get 1 over 2. So it is like that. So 3 over 2 minus, so this is 1, we just put them with the same denominator, so we get 2 over 2 is equal to 1 over 2. Okay, and this is the solution. So we get as a solution for x 0 and for y 1 over 2. Let's see, we can also verify if our solutions are correct or not. We verify if our x equal to 0 and y is equal to 1 over 2 are valid for this linear of equation. So x plus 2y is equal to 1, right? Let's see here. Instead of x, we replace it by 0 because we got 0 for x. Then plus 2, we take it from here, so 2, we don't touch it. Then y is 1 over 2, right? We take 1 over 2 is equal to, we get 1, right? So we get 1 here also. They are equal, right? So this is true. Second equation here is 3x, 3 multiplied by 0 plus 4 multiplied by 1 over 2. And this is equal to 2, you see? So this is also true, or is always true. Okay? Let's continue with this example. So here we see that we have 3 variables, x, y, z. Okay? As we said, first step is we convert the system of linear equation into a matrix equation. So we take, here we don't have anything, this means 1, so we put 1 here, 2, 2, and 3, 3. Okay? Then, if we don't have anything at the position of x, this means we have 0 basically, 0 plus. So we put 0 here. Okay? Then we have y, this means we have 1 here, so we put 1 here. Then if we don't have anything at the position of x, z also, this means we have 0 here, so we put 0 here. And we do the same here at the position of x, we don't have anything, so we put 0 plus, so we have 0 here. Then we have 2y, so we put 2 here, and 1 here, we put 1 here, right? Then how many variables we have? 1, 2, 3, x, y, z. So we put x, y, z is equal to, we have 1, 2, 3, so we put 1, 2, 3. Okay? Then second step is we find the inverse of the matrix. So this matrix 1, 2, 3, 0, 1, 0, 0, 2, 1, we have to find the inverse of this matrix. I already calculated the inverse. Okay, if you don't know how to calculate the inverse of 3D matrix, you will see a card will appear here, and you can click and see how to find the inverse of this matrix. Okay, so now third step is we multiply the inverse of A, okay, the matrix A, by the side after equals. Okay, so we take our inverse, we put it here, multiplied by 1, 2, 3, 1, 2, 3. This is the numbers after equals 1, 2, 3. Okay, and this is equals to, first row we said it is for x, second row is for y, third row is for z. So 1 multiplied is x is equal to 1 multiplied by 1, 1 multiplied by 1, plus 4 multiplied by 2, 4 multiplied by 2, minus 3 multiplied by 3, minus 3 multiplied by 3, we get 0. Okay, then for y, y is equal to 0 multiplied by 1, 0 multiplied by 1, 1 multiplied by 2, 1 multiplied by 2, and 0 multiplied by 3, 0 multiplied by 3 is equal to 2. Okay, final one is z, 0 multiplied by 1, 0 multiplied by 1, minus 2 multiplied by 2, minus 2 multiplied by 2. I think it is now really clear for you. Final one, 1 multiplied by 3, 1 multiplied by 3. Finally, this is equal to minus 1. Okay, and if you take 0 and replace it instead of x, 2 instead of y, minus 1 instead of z, you will get 1 here. Okay, thank you for watching.